The stream should be on.
Have you ever heard of homomorphic encryption for deep learning?
Again,
homomorphically encrypting the data and then training a model on that?
But what you mean, like try to make a model that can encrypt data, right?
No, the data is already encrypted and you can train the model on the encrypted data.
To decrypt or?
Not to decrypt, to train your model and yeah, just do the training process on encrypted data. So it's more private. Have you ever heard about it?
In that way. Yeah, there is all sorts of methods, like for example, also when there is, these content moderators, and they need to look at the nasty videos, and then there is also personal data. Then they change that you cannot see faces or something like that. So then, like,
that's all what I'm talking about. The data is actually encrypted beforehand, and then you pass it to your whoever trains the model, and then they can train the model and get the exact same results on just encrypted data. So that you can keep your privacy.
You even don't know what was the data about, right?
They don't know.
Mm-hmm.
If you give the data to Google, they don't know what the data is about. It's fully encrypted. They can't trace anything. They just train the model, and that's it. They never get to know.
Yeah, it's a interesting line of thought. If you're saying that you encrypt your data and then pass it to deep learning model to learn the outcome that is also encrypted, right?
The outcome is not encrypted. So,
but
at least I think if you want, they can manage to give it to you encrypted, and you are the only person who can decrypt it.
Yeah, again, so remember we talked about this. So the data set, let me put it on. So the car price prediction, right?
Yeah.
And the model then learns that this parameter, it has the values from one range to another range. This is a categorical parameter and so on. So in one sense, you already could think that that's kind of encrypted. It's not really encrypted, but it's just when it's normalized, and when you just reduce it to the dimensionality and the scales. So then if some data engineer looks at that, it cannot really tell what is it, right?
But if you rescale it.
Yeah, but if I don't give you the parameter, like these parameters, so it's kind of from that perspective that's already kind of obfuscated. But then another thing is, like if everything is obfuscated and you don't know what was the data originally, then it's also might be a problem to know what kind of normalization put and why should we include that or not include that, and
okay.
it's kind of like it's difficult problem, but it's interesting. Yeah. Okay, so this is this. Okay, so before moving on, I want to quickly look at what's the status on the last task we did at the class. Because I think we tried to do the classification of remember, was this a fuel type of the car, right? So just maybe you can pull up that homework, not that homework, but that code, so we can just make sure that everybody gets it working, because then it's important, because the next topic will be built on that one. So if there is some serious issues with the classification task, then the image classification task will be even more difficult. So just a second, I'm looking at the situation. So the one person actually did the binary classification as well, so that's great. I can look at that as well. So Finn, who is Finn again? Please remember. You did the binary.
Yeah, I tried it.
Okay, we will look at the code. Sorry if I don't yet remember all of your names exactly, but I will try. I know Žarko, now I also remember Finn probably. So okay, we'll see. We'll look maybe all together a little bit as well about the what did you do there? It's binary. Okay. Like from first glance, looks about right. We'll see. Then the classification task was accomplished only by 4 people. Okay, so Galina, Finn, Fabian, and Bach, Bakhtiar. Bakhtiar, yeah. Yeah, so.
Did you do the entire task? Really? No.
So yeah, well, that's great for those 4 people, but then that means basically that we need to pull up that task and make sure that everybody can submit it at least. So we'll get it quickly back on. So where was it? Classification. So here is, okay, we'll actually share it on my screen. Yeah, so this was the classification task as far as we got it. I don't know, maybe the people did not submit it because there was some extra tasks. Let me see. So there was the confusion matrix and F1 score and the weights, but weights already we did. So is it that the confusion matrix was the problem, or was the or just it didn't work at all, or what, like the code didn't work? Can I help anyone? So I will just show maybe those parts as well quickly, but let's see. So this was how far we got. If I run the code, okay, it was not working good last time, I think. Let me see. Let me see. Let's check out what's not good here. But if I remember correctly, that if I disabled weights, then it started working. Let me see. So meanwhile, while I'm checking this, please make sure that your code works. I will go over and see, can I help? So, what does this does not like? Not totally sure, just a second. So let's see, where was it? What was on the slides last time? Cool, categorical cross entropy. Here the last, I think last usable slide.
Share the code also for the next days, like that we can copy.
Oh yeah, sure. Like if somebody is already done, yeah. So I'll.
With the other keyboard layout and things like that, it's a mess too.
Yeah, no worries. So yeah, we'll just share just a second. So the yeah.
I mean, sharing this so then we can also copy it like the other guy did.
What
or
do you mean?
just a screenshot for sharing.
No, not the screenshot.
The actual code.
Code. No, you mean it's problem to write the code, or what?
Yeah,
The other guy shares his entire code.
I mean, like while we type those codes, you're explaining and we kind of like behind some points while you're explaining.
The idea is that if you write it, then I can go over it and help to fix it, and then you next time can write it yourself. Or like if you copy paste, it's like basically you don't experiment, try to do it in any way. It will just make sure that other guys don't copy code for you. So that's thank you for telling me that. So we'll see the other things. So there is something in regards to these. So meanwhile, you can, if somebody is missing this thing, you can look and try to make it work. I will go over to help you, but I'm just right now looking what is up with the accuracy, because something is not right, but I will quickly find what is not right. and then we will. The plan is hopefully by the end of today, or at worst early tomorrow morning, to break first CAPTCHA image, and then it will get even smarter and smarter ways to do this.
What loss function is it?
So this is the so this is, as you see, this is the simple categorical cross entropy, the mean value with minus in front, then the vector of the real one-hotted and hotted class, the weight for each of those classes. So the weights should be the same shape as those maybe that's the point, we'll see. No, but I selected from weights the indexes. So for each class, for each sample, there should be weight. So how important this is for the loss logarithm, predicted probability, and just the numerical stability. And this part is actually on the top part of the data set, and it's just calculating the what are those weight values here. So this is one formula. You can use some other formulas as well, but this one uses the number of occurrences. So 1 divided by number of occurrences multiplied by the sum of all occurrences. We can look at that equation as well just a second more. Just trying to make sure that I find what is the reason why it doesn't give great results. So I found that formula actually is a little bit different. This is okay.
Yes, the last one in Python. It's yeah. Or maybe four depends on the.
Okay. Okay, we'll see. So I will go back to the code. I will explain also a little bit more that formula. Okay. Where's the? Let me go back to the code. So here again, I guess this one was a little bit not understandable from where the weight comes from. So dataset full, there is the in dataset full in the constructor in the init part, right? There is these few lines of how to calculate the weights for each of the classes. Again, so right now, okay, so this is 0.1 actually. Is it 0.1? Okay, let me
But
see.
why do you calculate the weights? I thought they are just randomly given and then you try to.
Okay, again, yeah, that's a very good question. Again, I was trying to emphasize that. So these weights, these are not learnable weights. So these are class weights, basically class weights.
To balance the data.
Yes, because the data set is not balanced actually.
Yeah.
So this is not the learnable weights. And again, there are some interesting things. So maybe that's why it's not good idea just to copy. If we add here the breakpoint and look at this. So first of all, the y value means the all of the labels for the data set. So see, sample number 1 means that this is the petrol car or diesel car. The sample number next one is the diesel, petrol, diesel, and so on, and then there is the LNG and so on. So these are the samples that we want to predict. And then this counter, so the counter, if I press here, it will get me up here. So the collections from counter, there is this very useful small class utility for generating these lists. So the dictionary is basically, it counts all of the occurrences of the element. So this is built in Python like a class function. So it creates that there are 4,000 occurrences of the, if I remember correctly, that was diesel or petrol? Diesel, yeah. So 4,000 occurrences of diesel cars. So here. So 3,600 of petrol, and then the others. And then when we have those values, then the next thing what we can do is get them in one vector. So you see here, actually it's very nice that we can see these values here and here. So now it's like 4,000, 3,057.38. But then it's a problem. If I just multiply these guys to the respective samples in the loss function, it will give me exact opposite effect, because those which are the least found should have like these should have much higher effect than these ones. And then there are multiple ways how to calculate this effect. So one of the kind of simplest way would be just so let's say alternative methods for weights. And we will maybe try out. I think that might be something to do with this, that that the formula right now is not optimal. We'll see. So then the alternative methods could be, one could be like this, so that I set 1 minus the y counts divided by sum of y counts. So now all of the weights would be in a range from, we can even try this probably. So all of these would be in the range from 1 to 0. And now it says that these two have much higher importance than these two. So that would be one way to do this. Another way could be...
But that's still not good, because you want to have balanced importance, right?
Balanced importance. So
I mean, the importance of the latter two are almost twice as much, so it seems unbalanced, and I thought that's what you try to avoid.
So so what do you mean? Like it should be bigger difference or what?
No, a smaller one. It seems like the latter two values are far more influential than the prior ones.
Okay, let me show you some more. Maybe that makes sense. So here we could also use the max version, but then we need to somehow avoid that there is some guy with 0. So let's add some extra, I don't know, like plus 0.2 or something. So if you have it better idea, you can also offer some better algorithm. But now you see that, so there is some minimal threshold, and then there is like huge difference. If you want even higher difference, you can have like smaller threshold, and then basically you can do something like that as well. But it's any of these methods are not really great, because even if I will produce that these two guys have like huge significance and these very little significance, then also might have undesirable effects. So how could I show you that? Maybe I'll drop quickly to the Jamboard and explain why this is not always the best idea. So here, remember what we were drawing this plot. So we had the loss function, right? So there would be the loss here, and right. I will remove that stuff. Let me see. Where was it? Okay, good. So yeah, so the loss, right? So and then on the x-axis there is some kind of all sorts of inputs, right? So and then it goes like this. So this would be L2, and then we get for example now the petrol car or diesel car, which is very, very often found, right? We will have a small jump, and then if we get some I don't know, like so this will be the LPG car. This jump is calculated by the gradient times grad times learning rate times this weight, by the way. So because now we added the class weight in the equation, so then this is the length of that jump. And now if I have like this huge difference, just because I have few samples, this will jump forever from this side to that side. You know, it will never get closer to where I want. I want that these rare guys have larger jump than the more often found samples, but I don't want it to be too much, you know. So that's why, even though mathematically you would think, okay, let's make it the correct proper proportion, in practice it will just make things worse often. So then one way to resolve this is by using these kinds of equations with the division on top of it. So now again it's quite a big difference, and probably this is what it caused the problems. And then if I change this top term to some other coefficient, I can try to smooth out that difference. The way, I don't know, maybe the sum method is even okay here. No, it's still quite big difference. So okay, let's try out two methods. So first of all, I can smooth it out by this one. Again, you can use your own formulas as well if you want. So smooth out by this one, by putting at 1. Okay, but then still not good at all, the accuracy. Okay, it's doing something. Also, okay, while fixing the accuracy thing, well, let's make the confusion matrices work. In that way, we'll be more informed what is wrong with the model. We will see which class is in the wrong location. So the confusion matrices defined for each of the epochs here on the line 185. By the way, I hope the air is falling, so go check that. So then, yeah, so the confusion matrices is given there. And then what we want to do, we want to go over each of the samples. So here's the X, there's the Y predicted. And I add to the correct cell of the confusion matrix. We have 4 cells, 4 types of the fuel, right? So we want to go to and add to the correct cell. So for let's see, I in range of len of y idx. So it doesn't matter really which one. That will be basically the batch size length. And then in the that's very simple. So then the confusion matrix here, we first select the rows are the predicted as it's written in the plot. So the predicted ones, comma, the real ones. So now we select our desired cell, and in that desired cell we just add 1. So very simple. So now we added just 1 in that desired cell. So I think there's something else need to be added here. Some confusion matrix train that is added. I think it might even start working just by running this. We'll see. So now 10 epochs. Yeah, I think we start getting something. Yeah, we see very extreme tendency to predict these rare classes CNG and LPG, which is definitely not what we want, that it only predicts those guys. So
in my case the cell is just blacked out, so you can't even see the number, it's just black.
okay, we'll go check it. We'll also check the errors. What's blacked out? Yeah, so it's just focusing on that one. So the blacking thing is you could modify it. I think it's already done like that. Let me go here. Yeah, remember this thing? We commented it out. If you comment it out back, you will not get blacked out. You will get the white letters there. So see, if I run it again, when I comment out the percentage, see it makes white letters. So there is a small line of code that detects should the letters be white or black in the plot. So, okay, so this is then also we'll add to the Jamboard. This line, make sure that you get at least confusion matrix working, and then I will also put in the Jamboard those few weight examples, and I will add all of these things maybe to slide 20 to the same previous Jamboard probably.
But I get an error message if I...
Yeah, I will come just a second. So again, I'll just explain a few things. So while I'm going around making sure that you get so far, at least those of you who are so far, you could try to like play around with the weighting function, or even remove it at all, just to make sure that the confusion matrix is starting to look better. So the better confusion matrix means that more values fall in the line where the predicted and true value matches. So this is this. Okay, that is that. Please, okay, you're closing. So we'll come back just make sure that the air is full. Can I help anyone get so far? Did anyone find also the way how to improve the weight function?
So the thing they did not say I have enough.
Okay, so then you need to wait for the next template. It will be a little bit later. So
We need to do in this time.
yeah, so so it says that you need a confusion matrix there, yeah. So scroll up. It should be somewhere confusion
That's
matrix.
it, I guess.
Yeah. And what's happening there? So that
I'm using the NumPy in the area and not the sensor.
what do I have here? It's how can that be? So
It's in line with
no, it seems that when you go to confusion matrix, please, where you add these numbers to confusion matrix, this line which I have on the C, where do you have this line?
So
You can see, I think I see it. No, where it's highlighting this thing. Maybe I'm fine. Maybe because this should be actually here, but I really don't think that that's the reason. Try to run it. Okay. Okay, great. Okay, try to change it to NP. Now run it. Now it will work. Can I help you? Yeah, you also have the situation that it's highlighting only that.
oh, you're right.
So yeah, we'll try to let's try to play around and try to make it that you know that the confusion matrix looks better, because now it doesn't make sense much more. So for the first thing, what you can do, you could just try to disable weights, right? So one way to disable weights would be just using like this. So MP ones like this. Run it. Now everything falls into completely wrong category again. Definitely something is not okay. Okay, so maybe there is some other kind of bug. Okay, we'll see. We'll find it. Okay, so this is definitely something not okay. So we'll remove here. Again, you see, if you add the confusion matrix, then we at least understand what's happening in the model. If I just don't add it, I don't know really what's happening. So now definitely again not good. So what is expected? Without weights, at least the petrol and diesel must be classified with respect to each other very well. But if I cannot classify those two, then it means that something is very, very wrong. So here I will add the breakpoint, and let's look what's happening here. So Y 16 by 4. So Y values. Need to double check that these are correct. 0, 1, 0. There is something changing. Okay, that's correct. So Y prim values. Something is there. At least the shapes look all right. model. I don't think this should have effect in any way. And that's not it. So 16, or oops, that's it's okay. Okay, maybe here something is off. Let's see. Watch the tensor size, the embeddings, embedding size 8 times 3, 24 seems about right. Then that thing as well, 28 seems about right. What about the x's themselves? X4, these look okay. Y prime and then look okay. What's up with this? Something is not okay if it's not training yet. What is the learning rate? Let's see. E minus 3, fine. What could be the problem? Okay, we'll try some quick things first. So model, just try to make it a lot larger. 100, 100, 100, and try to make it to level maybe, but if it will not have effect, then it's definitely not model. Whoa, what's happening? Okay, here as well, 106, right? Run. Yeah, it's definitely not model. So model is not the problem. Maybe data set is problem. So here, the Y range. By the way, those of you who finished this work, did you get any of you get higher accuracy or not really? No higher accuracy, yeah?
No.
Okay, but that's good. We will find the reason. So it's something strange.
I'm watching you how you fix it.
Yeah, like I believe that if you don't don't know how to look at, then it's also not good. So 0. So this is this.
But I thought if you can't find it, I can obviously not find it too. So.
No, if you look at what I'm doing, then definitely you should be able to start getting the way how to do this. So y. So y values is 1, 0, 1, 1, 1. So here this is correct.
I've honestly lost the overview over the entire program because I'm used to working in Jupyter Notebook where everything is possible.
Okay, you mean
and also Keras, too abstract.
Yeah. So, but basically the Jupyter Notebook. So there are some pluses, minuses. Like for example, if something is not okay in the beginning, then like again you need to go over everything and see if. So anyway, so here's the mean values. We'll definitely find the reason what is happening here. Does anyone else have some kind of code errors? You know, if there is any code errors, maybe the guys who have finished can help out, please. Just don't sit around if somebody have some error while I'm finding this problem. There must be something interesting here. We will find it definitely. It's not model. Okay, I will go to the numpy here, we'll see if that helps. So data numpy max -1 access numpy -1 NPE accuracy. I think it should have any difference. Yep, it does not have any difference there. This is puzzling. Just a second, we'll try replacing big chunks of code. Let's see if that helps. It's definitely not model.
Is it correct what you're doing with the train test splits? Because you assign the entire, would you like look in just line 84 to 91?
Train test split, right?
Because you're assigning the entire train test split to your train test. Is the entire data set?
The dataset full is full. So okay, well, you can. That's very good that you're starting to look at some details in the code. So the dataset full, then here, and then the this sklearn train split. So what it does, it just gives you the indexes of that dataset, which follows some condition. And in this case, the condition is that I want number of this samples in train and number of data in test, and then the main condition also is that stratify ensures that the same kind of class balance that was in the train will be also in the test. So that is that, but it seems like that there is.
I had a pretty similar problem myself where the index wasn't matching the actual data values. So.
Yeah, if there is some kind of shift in index or something like that, then definitely something like this can occur. But we can see that there is some problem. Now my plan is just I will use some of my old code, replace a lot of chunks, and quickly find where is the issue, because it doesn't make sense if every time I run it, it just gives those two like the one class up there, and it doesn't make sense how it's like again. So I changed the dataset, changed the other things also did not help. Okay, what else can I do? I will definitely find the problem. Just give me a few minutes. Just a second. There must be something off here. Now let's change the for. Oops. Now you know that it's very important to have some more metrics. If you just have the loss function, everything goes down, everything is very well. In reality, everything is very bad. Replace the whole chunk below. This is mysterious. This is not that. Okay, loss function itself. Must be some kind of strange typo, probably.
No, it's surely not the loss function, because it doesn't work with any loss function.
Doesn't work with any. What do you mean any?
It's not good. It's always very bad accuracy.
Yeah. Maybe there's multiple things going on. We'll try to change model and loss function, but I don't think.
But even though your model is not complex, it should at least be a bit better. Maybe like 50% or something, not 20.
Okay, now it's working. Okay, something went better, so we'll see. What did I change? What was the difference here? Something is different. We'll see. We'll break this. So before breaking CAPTCHA, let's break this thing.
What this we fix? Also ich dachte, deine Accuracy ist so. Du zählst ja, dass deine Hauptdiagonale quasi schwarz wird. Dann bist und ganz anders. Aber das liegt auch daran, dass er den Code jetzt noch nicht gefixt hat, weil da auch irgendwie ein Problem besteht. Also wenn die Accuracy hochgeht, dieser Wert, den wir da messen wollen, dann wird auch irgendwann die Hauptdiagonale immer dunkler. Und die anderen Felder sollten dann weiß werden.
Drei bunte blaue Felder und dann haben wir zwei grüne und schwarze bekommen.
Weil wenn Hauptdiagonale, dann heißt es dein realer Wert und der Vorhersagewert sind gleich. Das wird ja erreichen. Das ist der Model den Wert, das hat der Mensch mal gesagt, das ist jetzt ein Diesel-Auto. Und dein Model soll ja auch vorhersagen können, das ist ein Diesel, das ist Benzin und so weiter. Und wenn das Feld sich etwas in der Mitte trifft, dann ist das auch der Fall. Und sonst ist halt irgendwas uncool.
Okay, I can share and you can try to help me find what's up here. So that's a little bit funny. Well, I try to compare one of my old models with this one, and there must be some kind of typo which I don't see. Let me see. So if I drop here, maybe. Oh no, it's not here. You can see it. Oops. Duplicate. Meld. Where's the meld? Here. Okay, now, yes. Now things. So this is the comparison of code between what I have and what was before. So one works, another one don't work. Oh, it's so small. Where's how can I make larger letters? What is this? Okay. Okay, it will be larger. Okay, anyway, we need to find the difference here. So one is that the relu function, but that cannot be the reason. -1 also cannot be the reason. X embeddings cannot be the reason. You really don't see the difference. So what I can do, okay, so not make it crazy long trying to debug this.
Does it make a difference what parameter you pass for your Y prime for the forward?
But the parameter which I pass is derived kind of the same way in both ways. Just the name is different. Something strange. Anyway, so like just to not make it super long, I will go against what I said. So I will just share example of working version from before. Well, like which I like. It's like from one of my old codes, which is basically, you know, there's different way of coding things, but it's basically the same. It's just there must be some kind of typo there, which I cannot see. So just again. So I'm sharing this now. And if somebody then later can find what is the problem, that'd be great.
Extra points.
Yeah, I definitely will give extra points for somebody can help me find what's like. I cannot see it.
But do you share where do you share your code?
I will give a link just in a second in the classroom. So classroom stream. So the let's call it the car classification. code example, working example. Okay, and that's it. Well, I don't want to spend any more time on this. We need to go on. There's definitely some kind of typo bug or something. Okay, so today we're going to talk about the convolutional neural networks and the ConvNets or convolutional neural networks. So we'll see.
Or
Sorry?
what's the link you wanted to post for the code, for the working code?
I posted for the previous one. I posted on the Google Classroom wall. So let me show you. So here on the classroom wall, see car classification code working
Yeah,
example.
I think I
So
have to do
you
that.
can get it. Yeah. And now let's jump into the classification tasks. So for the image classification, yeah, okay, let's. So the image classification. So the so idea for the image classification, I think one way to look at it is to see the difference between the way how the simple classification worked. So NLP classification. Okay, so we'll drop some example. So here, so the simple classification will take some input features in one dimension, right? We have in one dimension the car year of make, the how many kilometers driven, then maybe also a few other embeddings concatenated together, like the I don't know, like is this the first owner, or no, maybe is it like a manual or automatic car or so on. Then there are some hidden layers in between nonlinearities, and then the is this a manual or automatic car, for example. So all sorts of so very simple procedure. So first the inputs, then the so it goes by linearities and nonlinearities in the middle, and then the probability distribution output, this output. So but then the convolutions work a little bit different way. Initially, the idea was also Jan LeCun was the inventor, the same guy who is the Facebook AI director. So and also like the ones in the before the previous AI winter already was working on deep learning. So then the idea is that we're looking at two-dimensional inputs. It can be also multi-dimensional. It can be three-dimensional, four-dimensional. By the way, if you have two-dimensional input and so so you have video, you could just put the video frames one by another, and you will have three-dimensional input. It can also work with that very well. So then basically you have this two-dimensional input. It's not anymore one-dimensional, so that's one difference already, two-dimensional. Then the other difference is that we're not just putting all of the image inside these hidden layers, the linear layers. We are putting only parts of the image. So if I would want to have like this robot image, I don't know, it's like 100,000 pixels by 1,000 pixels, very detailed, and then I want to put like many non-linear layers on top of it. It will take a huge matrix multiplications, and it will just fill the whole GPU just by this one image. It's like not very smart way to utilize limited resources. So initially that was also the idea. They wanted to make that the resources are efficiently used, and that's why they started using these kernel functions. The kernel function basically means that I have some kind of mathematical function which I apply to the whole domain of the data, and it can be not only the image data. It can be, I don't know, like sensor data about like I don't know, like the greenhouse. There's like tomatoes growing. There is the sensor data points about all sorts of things like humidity, sunshine, the day of the time of the day, the how many tomatoes is growing, like all sorts of data, and then all of this long vectors of data. We have like huge database. Then we can apply kernel function to all of that database, and for example project it in low dimensional space so that we as a human being can see it. So again, the kernel functions are not only for the images. That is the main point. It's but we can use it also for this convolution type of task. So there is this small box. You can imagine as a box. We will look at that and code it ourselves. So it goes from the one corner till the other corner with a small step and produces the feature maps. So this is the kernel, this small guy. Then this is a feature map. And then the new feature maps have different kind of dimensionality than the original input. That is achieved. So you can think of either repeating that kernel operation many times. So I have like here 4 kernels separately. So first kernel goes over the image, create one map. Second kernel goes, create a second map. Third kernel, third map, and so on. Or you can just create a dot product that would produce the extra dimensions here. So just project it on more dimensions. So then do the same thing again. At the end here, what we usually do is maybe do some kind of mean value for each of these maps and just create one point, and then concatenate those all points in just one dimensional vector. And then when you have one dimensional vector, you put this guy at the end here. So kind of the outline of the structure. It will go deeper as well. So here, another way to look at this. There is the idea. We have 3-dimensional input, RGB, red, green, blue pixels. All of those are these input maps of this image. So I guess they wanted to have the cat in the image. And then the kernel itself, so they call it here the kind of patch. Well, actually, this is, I guess, this is I guess the kernel. So then it goes over with a small step, like it's called the stride, over the whole image, and calculates the dot product of those images, and you get actually it looks a little bit different, but then we also sum the dot product. So we sum the dot product by the x and y axis. We'll keep looking at those images and also one animation, and then you will understand, and then we will also code it. And when you code it, you definitely will understand. Okay, so I guess this one will be better to explanation.
Instead we sum the
this
product, but we
see.
could also just take the maximum value of our kernel, right?
It's usually just, so the maximum value is definitely not good idea, because we want to have the gradient flowing through all of this kernel, and the maximum value will just flow to the one cell of the kernel. So it's much better to just use the sum of all of that thing. So here the idea is again example here. So the kernel is going over. So we are doing the so basically it's kind of the dot product. So just multiplying all of these guys together, summing them all together, and then placing into this the location in the new feature map, and then you go another step, do this all the time until you get. And this is, by the way, just for the one of the channels. So the dot product comes useful when I have not one here, but I have RGB. So I have 3 channels, and I want to do this at once, not just for the one channel. So that's why it's also useful there.
Why do you have a field of 9 pixels for one value? Are you going to reduce it afterwards, or are you going to leave it like that?
All right. So there are multiple things going on here. By the way, I just realized I had one other picture which would be nice to share. So again, maybe I can write it down also something. So this is called kernel. You can configure the size of this guy as you want.
Yeah, no, but I hope you're getting my point, because in the feature map you have 1 pixel minus 8, but you have a field surrounding it of 9 pixels. Why do you have 9 when it would be way more?
No, it's
It's going to be reduced afterwards, right?
So you definitely need to include all of these values in the kernel. It cannot just float outside. But if you look carefully here, there is interesting thing. So here's the zeros by the line. See? So and those zeros basically might, I guess in this case in the bottom part there is no zeros, but basically usually you add padding. So you add padding so that you make sure that the kernel covers the very corner of the image.
Yeah, because some regions are not as often decovered as others. But
That-
I'm
yeah.
talking about the new pixel value destination pixel
Yeah.
on the right side. So your side is
I think the illustration here is it doesn't. So basically, in reality, what you actually produce is this field, right? So it's not really. So this just an illustration. It doesn't mean that that there is actual same size feature map. But for the size itself, it does matter if I add a padding or I don't add a padding. If I don't add a padding around this image, right? It will just become way smaller. If I add a padding, then I have option to try to make it the same size, you know. So that is important definitely. While I'm waiting I'm quickly finding some other stuff because I remember I saw one nice picture, also in 2 dimensions, which I want to show you. Mhm. Oh, shoot. Where is that image? Because convolutions can work in more dimensions, in less dimensions, and in less dimensions in 1D. I think there was one nice way to show it. So here, was it? Okay, so here, a bit. Again, so we have an input of 8 one-dimensional. So this is just one sample, right? So the one sample with 8 data points in the one dimension, and then there is also added the padding even here. So and this exact configuration is really cool. So because it makes that the output is also 8. Because if I don't add padding and if I don't have few other configurations here, the output will be completely different. So the idea is that I multiply these guys together and then sum them together and put at the end here. I'm not sure that it's actually mathematically correctly done. But there is not values in the weights, so it doesn't matter. Okay, so here what you need to look at this is first of all there is a padding. So we add this padding. This is one parameter. Another parameter is kernel size, right? Kernel size. In this case, what is the kernel size?
It's 3 times 3.
Yeah, no, it's just 1 times 3, but yeah, 3, yeah. So because it's one dimensional, see? If it would be 2-dimensional image, then it would be 3 times 3, or it can be anything. It can be 3 times 9, 4 times 6, and so on. It doesn't have to be exactly the same size.
I thought in TensorFlow it's like you need to give pass a parameter for your height, for your weight, and for the number of channels.
Mm-hmm.
For
The number of channels is another thing which you'll just quickly get it.
In TensorFlow you definitely have to pass for the height and the width.
Yeah, height and width. Yes, in this case, this is the height is basically 1 and width is 3, right? Or in this case, it's just one-dimensional input, 1D input. So you can use it for 1D input, for 2D input, for 3D input, for 4D input. It doesn't matter. So this is mathematical procedure. You will see it. So basically, so this is that, and then the other thing is here is the stride as well. So stride, with what step I want to move this kernel. So once here the stride is 1, I'm moving by 1 step, right? So that is that. I'm thinking if anything else is missing here. I don't think there is. So, and then there is the formula to get out this this result. So why especially this kind of configuration is interesting, because if you choose the padding 1, kernel size 3, stride 1, you always get the same output. also in the two-dimensional case. And here, just want to make sure that you get this, is that so the output of these convolution functions. So here you see that these are these feature maps. So these are the intermediate outputs, right? They are very important because at the end we need to know what is the size of this guy, because this, what we already did, these models. Remember, if I change the not correct channel count, everything falls apart. I cannot just like pass any kind of channel count I want. So I need to calculate this, and to calculate this we use this formula. So this formula means what is the input of the image, or the this vector, or this width or height, and what will be the output after this operation. So there is the 2 times padding minus kernel size divided by stride plus 1, and then you get that this feature map reduced by this amount, and then I can calculate the next layer and so on. This is quite important stuff, because like you want to make sure that at the end the result that you get is actually getting through this last fully connected layer. So we will look at some ways why this is important, how to improve it. Then I definitely want to find that, I think it was in the links which I gave you already so here, classroom, materials, there is one, this Stanford link, where there's a really nice animation. Again, the similar things which you just discussed. So this is the simple 1D model. Now we have this convolutional model, where the outputs of these layers are not just one-dimensional, but they are multi-dimensional. Yeah, so there's goes the kernel. So by the way, the first kernels, like in the convolutional network, the first layers, when they are trained, they look something like this. And this is very interesting because even like 15, 20 years ago, people were generating these themselves. So they're trying to make some kind of kernels that try to encapsulate what is in the image, right? To find the edges and things like that. And then later, basically, we found out that models, when I put them to training, they find these things themselves. So any of you worked with image processing and know what I'm talking about, or not really? So I will show maybe some more examples. So here, if you use the Photoshop or something like that, they all have these kind of functions. So if I have this image and I apply this small 3x3 kernel with predefined values, exactly the same procedure, right? Multiply and sum them together. I can get, for example, edge detector. I can get the sharpening effect. I can get the blurring effect. I can, if I add the Gaussian kernel, I can. What else I can do? I can add the median, so it's kind of makes like artwork or something like that. So you can apply all sorts of these kernels manually, finding them. Okay, this looks like that. This looks like that. This finds me the edges. This finds me the corners. This finds me the rough spots. So and they like just those 20 years ago, people configured the first layers themselves like that, and then on top of that put the support vector machine. That is just a very primitive kind of linear regression, and then gets the classes of those objects. And if you look at OpenCV, have this cascade classifier which does the same thing. Then the MATLAB also have built in these cascade classifiers. So this is like feature engineering, and what you see here on the screen, this is what the model learns itself if you let them learn. And this is also very cool because these kernel values looks very similar also to how the opticians and the physicians, they have this thing called Gabor patches, where they test how well eye is able to catch the difference between the colors, and those look very similar to these ones. So they test human eyes by showing basically all sorts of patterns very similar to these what we see here. And okay, so this is this. So there is some like very simple NumPy code that shows the procedure. Remember, I think also Stefan showed you that the 2D matrices can be selected out not only by the rows and columns, but also by small squares, right? So I can select these two rows and then everything from 0 till 5, and this produced me very nice 5 by 5 square, right? And then also these extra channel dimensions. So this is this, and then here is this nice thing, I think, which demonstrates the best what's happening here. So this is the kind of small animation. So I have this RGB color image input. I have 3 trainable kernels. Oh no, it's actually two trainable kernels, sorry. 2 trainable kernels, and then I do these basically dot products, sum them, put them inside these locations, and go by the stride over the whole image. So is it clear the kind of the algorithm operation, what's happening here, or not really? What's not clear, I can try to show more examples.
So each of your kernels has several filters, and each filter in turn has several weights.
Each filter has
Reading
several weights.
correctly.
So each kernel is
Several filters, in this case W0, W1. And then you have several weights. And
okay. So so there are a few things. So each kernel must contain the number of channels that is equal from the previous layer. So here there are three RGB, right, channels. So it means that each filter, or the filter equals the kernel basically. So each kernel must contain the channel count as in the previous part. So the next guy here must have 2 channels, because there is 2 output channels, and this one can again make it to the 4 channels. So the rows here, that is not separate kernels. The separate kernels are here, the columns. So the first kernel, second kernel. And one operation is just to do it very manually, just to do exactly what is animated here. That you can have these 3 separate channels for each of the kernels, go around, multiply them correspondingly, sum them, put in the cell, and so on. Or you can kind of do this all at once by putting both of these guys inside the just in one matrices, and then do the dot product on those locations. We'll do that.
And why do we have
Yeah.
2 output channels?
2 output channels. Why? Because we have two
Filters.
yeah, 2 kernels. It's like a intuitive way is to look at that with each kernel I'm going around the whole map. So if I add another kernel, again I go through the whole map, again I go to the whole map and produce the output, right? So that's how it works. Okay, I need maybe more intuitive things and then actually coding, because again, yeah.
The last dimension could be n-dimensional, and the more filters you have, the more features you extract.
Yeah, but it's that's also a great point. Let me show you again back here. So maybe there is some better image. Just a second. That's correct that that the output, those kind of filters or kernels, or the output channel is very important, because it makes it exchanges the width and height. So the size of the image is compressed into this z vector. Basically, it makes a larger dimension in that direction than in other direction. Maybe where was some kind of image? Find it. I will find it. So it was actually in this guy here. There was somewhere. Okay. So see, like initially we have very large image, right? The high resolution. Then we get like a smaller resolution. Every time when we get a smaller resolution, we get more channels. Z dimension becomes larger. So it's kind of exchanging the resolution to the depth, and the depth is kind of encoding what is inside there. At the end, what we want is that here it's encoded the highest level features. That's kind of the most important things, which are like not just in one location in the image. Just a second. I want to find one more picture. Oh, there was what was the name of that? It was,
so you're actually compressing it spatially, right?
yes, but there's compressing the kind of information there. There is the one there are some problems. Maybe you can. It's probably hard to tell just by that. Especially, it's not something that you like often do. But some of the problems is that. But before talking about the problems, I want to show the Convolutional Network. There are some really nice pictures to show what is inside the convolutional network itself. Okay. Okay, this will be, maybe it will go wrong. We'll see. So, so here is the one of these. So distal is kind of really nice, very visual, small journal for scientific like papers. And here's some of these layers in convolutional network. I hope that there should be able to see the difference. Something interesting here. So the lower level kind of features. Okay, this is just categorizing the inputs, I guess. So if I'm interpreting this correctly, so the lower level values kind of are more the colors and just the edges and things like that. And then the higher level values you see already are looking something like really some objects, you know. So the higher level feature maps, you see these are like birds, right? Similar to the birds. These are similar to the chimpanzees and some kind of apes. Then there is like lions, dogs, and things like that. So you construct them from low dimensional kind of very rough features, which are, so here there is some features. So like corners, like colors, like textures and things like that. And slowly it becomes something that is combined into one thing. Do you get it? So we can see, so there's like more like a balls, like actually not just on textures. Then if you go deeper, then it's even more combination between the textures and a little bit more like an object. So you go deeper, then it's separating out like these. I don't know. It's not that easy sometimes to interpret, but it's just that in the first layers, these are very rough kind of features, just the edges and things like that, and in the end they are like actually combined local objects. But then some of these problems, like we'll maybe return to them a little bit later, but is that first of all these models they are not. So it doesn't matter where this robot is located. So if this robot would be small, and or maybe this cat. So if this cat is small and it's located here or here, it doesn't matter because the kernel will go over it and it will recognize it, right? So it will catch it sometime. So but then it's a very big problem if this cat is small and then it's very big. Yes, there is no actually any kind of logic inside there to make sure that if I change the size, then it still recognizes that's a cat, you know. So that's one problem. Then if I start rotating the cat, again, very big problems arise. So basically, all of these things are not that cool as they look at first glance, you know. So there is a lot of ways how to try to avoid these problems, but the problems still exist. So and these are just few very small ones. Okay, so let's go to the code back, and just till the break we can start trying to implement the convolutional neural network. And we need this, of course, because we want to be able to decode CAPTCHA, right? To try to find what is inside the CAPTCHA. And CAPTCHA is notoriously not cool that you can just rotate it, squeeze it, and things like that. So you can imagine it can become very hard later. But it's not impossible. There are companies making money just, as you know, right now. The last time I checked was that any kind of captcha, image captcha, like these Google the Google tricky captchas, you know, these Google captchas where you need to mark where in these 9 images there is the car or something, right? You know that they collect your data labels. So I'm always putting the wrong labels there, and I like after like the 3rd try I get past. So because I don't want to give Google my data, you know. So because they're actually just giving time to time the real values, but mostly they're just collecting your data.
Did you know the founder of CAPTCHA? I think it was CAPTCHA and reCAPTCHA. It's
Yeah.
also the founder of Duolingo.
Oh, well, yeah, right. He knows how to make
He's
money
really
from
smart. He's really smart.
yeah from getting free labels from people.
Yeah,
So anyway, yeah.
Does Google then use your choice? Maybe you select the card
Yeah.
as kind of training set?
Yeah, exactly. Yeah, sure.
That's how they make money.
That's why. Please, let's not give them free free data. Just let's start choosing not time to time not the right value, so that they will need to invest money to clean it. So anyway, but again regarding CAPTCHAs. So the last time I checked that the doctrine on CAPTCHAs right now is the following, that it just adds another expense to the attacker. Basically, it means that the attacker cannot execute attack as fast, and they need also money for either buying these CAPTCHA breakers from the services or training themselves, you know. So you will know how to train it yourself, right? But or you can also buy it from, there's like lots of sites that sell CAPTCHA breaking models. You just upload to the API the link where you want to break it. They execute on Selenium on their end. They send you back what to insert in the website. You pass. Just pay them money. So it's not like any of these tools are not really like holding back any kinds of attacks. It's just making them more expensive, you know. So.
So you want to turn us into hackers?
I think there's even cooler things you can do with machine learning. How to, I think like at the level where you actually want to use machine learning for the hacking, you probably can automate on scale all sorts of crazy things which like normally like a team of hackers do, you know. So anyway, let's turn back to the code. Where is the code? Where is the code? Where is the code? Summer school. The template, I gave you the template given. ConvNet template, live. We'll try to go over it as far as we can now, and afterwards.
Maybe we can just quit a bit earlier to get on time to lunch. Then we can.
Yeah, I like the idea, but only there is one thing. Whereas the lunch is on 1 o'clock, right? No, lunch is 12, right? On 1 o'clock I have one meeting which I need to attend. So we will start about like 10-15 minutes later, about 1. Okay. So yeah, if you want to go now, lunch. Yes, we can go, and then.
That would just be wasted if we wait in line. So we
Yeah.
can just.
Yeah. So yeah, if you want to go now, yeah.
Be smarter, I guess.
Okay, yeah, let's do that. I will be around here probably.
But you could already upload the template. So that
Yeah, it is already uploaded, I think. So maybe I messed it up. So yeah, I did not enable. Sorry. So yes, so the first. This is way strange. Why it says kernel function. Okay, now it will be added. 5.2 template added, but yes, if you want to make sure that you get to the launch faster, then I guess go now and then come back and look at template later. Yeah, and then we will do the coding together.